Okay, as promised, we're going to do the quadratic formula, or all but the very last step, which I'll kind of leave to you. We have ax squared plus bx plus c equals 0. That's our general form of a quadratic equation. I'm going to divide through by a, which you agree I can certainly do. And the reason I want to do that is because I don't want to have a number in front of x squared. I just want x squared to be plain old x squared. So dividing through by a, well, I have to divide bx by a to get this, c by a to get this. So we have this equation. Then we ask the question, just as we did over here, x squared plus b over ax plus what is a perfect square? The answer is very similar to the answer we got here, except now we're working in symbols, and that takes a little bit more insight, a little bit more sophistication. Hopefully you can handle this. If you can't, you're doing fine if you just understand everything we've done. But this is a kind of an extra for those who can follow all the details. And those details are usually presented in the Algebra 1 book, whether that's covered at the very end of the course, because this often occurs very near the end of the course. That'll be up to the judgment of an individual instructor and maybe to whoever decides on the curriculum. And that decision would vary from class to class in a way that I'm not going to express an opinion on. Sometimes it's a good idea, sometimes it's not. Okay, now, before we think about this, I've made a change in notation over here. Remember, I had x plus a squared, x plus a, and all that stuff. I want to use this same idea, but say I've got an a in this equation, and if I have an a over here, that's going to screw things up. So I'm going to change a to h. Now, h is another standard symbol that we would use in this context, and that's related to how you shift graphs and so forth, and you're going to see that later. So it won't hurt you to see it now, but you won't understand how that relates until you get to that point. Okay, x plus h quantity squared is x plus h times x plus h, etc. It's all the same as it was before, except now I've got h in place of a, and I think I've replaced all the a's by h. And the bottom line then is, it's the 2hx that has to match your x term. In this case, the x term is the b over ax. So we're trying to complete the square here. We're trying to find the expression that goes here to make this a perfect square. What expression goes here? Well, it's the expression that has the property that the 2hx that you get here matches the b over ax. What's going to make that happen? Well, if 2hx equals b over ax, and what value of h makes that so? Well, just solve for h. You just got to divide both sides by 2x, and you get b over 2a. Now, I haven't written that out. I've just used it over here. If h equals b over 2a, then x squared plus 2hx plus h squared is going to be x squared plus b over ax. Remember, we chose h so that the 2h would be b over a. And what we get here is determined by that. It's going to be b over a, because we replace this expression with b over a, and let's do it. Well, this would be not b over a, but b over 2a squared. Then this is going to be a perfect square. So we manipulate our equation. Our equation was ax squared plus bx plus c equals 0. We're going to add b over 2a quantity squared here so that this is a perfect square. We've got to add b over 2a quantity squared on the right-hand side as well. And then we rearrange that, and we get this being the square of, the x squared up through the b over 2a quantity squared being x plus b over 2a quantity squared. And you should verify that by writing this out and squaring it. And then we subtract c from both sides to get everything else over here. We get negative c plus the quantity b over 2a squared. Now we're almost done. All we have to do is solve this for x. Now I'll give you a hint how to do that. I'm not going to do that for you. I'm going to let you do that. You can look it up. You look up derivation of the quadratic formula. You're going to see practically the same thing that I've written for you here. What are you going to do? Well, x plus b over 2a is going to have to be the square root of all this right-hand side, or the negative of the square root of this right-hand side. So you're going to have x plus b over 2a equals the square root of negative c plus quantity b over 2a squared. And you're going to have x plus b over 2a quantity squared equals the negative of the square root of the same thing. That is your quadratic formula. If you simply write that down, following rules of algebra, no superstition, no unjustified steps, you get the quadratic formula out of this set of manipulations. Okay.